One more quick Poisson distribution example. Suppose that the number of phone calls received by 911 service follows Poisson distribution, and on the average we receive 10 calls per hour. Okay. Now the random variable here is what? Random variable is number of calls received in a given time interval. Okay. Now sample space is what are the possible values for x? Okay. 0 or 1, 2, and on and on and on. And lambda is 10. You have to specify this is 10 per hour. Okay. Now what is the probability that exactly 3 calls are received in 10-minute interval? So what is the probability that we receive exactly 3 calls are received? So now we have to recalibrate lambda because this is for 1 hour. Okay, remember one of the requirement for Poisson distribution to be true, the mean value has to be proportional. Okay, so if it is 10 for 1 hour, then it is 5 for half an hour. It's 20 for 2 hours. Okay. So here we need to calculate lambda for 10-minute interval. So 10-minute interval, the lambda is going to be, you take that, okay, let's absolute reference that. Okay. So we divide by 6, then we'll get for 10 minutes. So there are 6 10-minute intervals in 1 hour. So divide by 6, that will give us the lambda for 10 minutes. Okay. Then we want exactly 3. So R is 3, right? Then we want the probability that x is equal to 3. And that would be Poisson distribution of that, comma, now the lambda is 1.667, okay, comma 0 for exactly equal to 3. Okay, next question, what is the probability that there will be at least one call in 5 minutes? So now lambda is, okay, this is for 10 minutes. So we can take that and divide by 2. That will give you lambda for 5 minutes. Or we can take that, and there are 12 5 minutes. So divide by 12 will give you lambda for 5 minutes. For 5 minutes. Okay. Now we want at least one call. So at least one call means the probability that we want is for 1, 2, 3, and on and on and on. Okay. And we cannot compute all of these individual probabilities because there are infinity of them. So we have to do the complement of this. So which will be, you set R equal to 0, find the probability of R equal to 0, so which will be Poisson distribution for 0, comma, lambda, and you want that one probability, okay, R equal to 0. Then probability that x is greater than 0 or greater than or equal to 1 will be, so that will be 1 minus probability of x equal to 0. So this will be 1 minus.